For this tutorial, we are going to use differentiation to find the equation of the normal to the curve f of x at a specific point. Now we are going to focus on the normal. Then what does normal mean? You can use differentiation to find the gradient of the tangent to a curve, and you can find the equation of the normal. Now we are focusing on the normal to that curve at a specific point. Again, let's say the tangent at the point A with the coordinates A, f of A has gradient f prime of A. You can use the formula for the equation of a straight line y minus y1 equal m multiplied by x minus x1 to obtain the equation of the tangent. Then we have this curve and we have a specific point A with the coordinates A, f of A. Then this is going to be the tangent m equal f prime of A. This we already studied before. Then the normal to the curve at the point A is defined as being the straight line through A, which is perpendicular to the tangent A. Then the normal, it means that it's going to be passing through the point A and perpendicular to the tangent, that is creating an angle 90 degree with this tangent line. Thus this blue line represents the normal. The normal is then going to pass this point that is specified and is going to form 90 degree angle with the tangent. Thus again, the normal is a straight line that is passing through this point and forming a perpendicular angle with this tangent. Then the normal is perpendicular to that tangent. Therefore, the gradient of the normal is going to be equal to -1 over the gradient of the tangent. And this is a property that we studied previously for perpendicular lines. Then gradient of the tangent is f prime of A, so the gradient of the normal is going to be -1 over f prime of A. So instead of writing m for the equation of the line, we are going to use the gradient for the normal, that is equal to 1 over f prime of A, because the product of the gradients of lines which are perpendicular or right angle is -1. And this is a property again that we studied previously. So now let's use these properties or this property to find this gradient for the normal. So if we say that the equation of the line is y minus y1 equal to m prime represent the gradient for the normal multiplied by x minus x1, then we can substitute directly m prime by -1 over f prime of A. So the equation of the normal is going to be y minus f of A equal to -1 over f prime of A multiplied by x minus A, by substituting the value of the point A and f prime, or the gradient of the normal. The gradient of the normal is important to remember its property. Let's take example 14. Find the equation of the normal to the curve with equation y equal 8 minus 3 square root of x at the point x equal to 4. Then we have y, that is f of x, and we have a point that is only identified by x, so we need to find the y value. The equation of the normal at the point A is given as you can see. So the first thing is to list the given. We have f of x equal to 8 minus 3 multiplied by the square root of x, and we have the value of x, that is 4. Then we need to find the y value. To find y, we have to substitute x in f of x. So we get 8 minus 3 multiplied by the square root of 4, that is x, equal to 8 minus 3 multiplied by 2 equal 8 minus 6 equal to 2. Then the given point is going to be 4, 2, which is going to represent x1, y1, the specified point. Now, the second step to do is to find f prime of x. So we can substitute in the equation y minus y1 equal m prime multiplied by x minus x1. M prime is not given, but we know that m prime equal to minus 1 over f prime of a. So we need to find f prime of a. So we can find the gradient of the normal line. F prime of a for f of x, that is equal 8 minus 3 multiplied by the square root of x, or we can write it x to the power half, is equal 8 will be 0, the derivative of 8 is 0, minus 3 multiplied by half multiplied by x to the power half minus 1. This is equal minus 3 over 2 x to the power minus half equal to minus 3 over 2 multiplied by 1 over x to the power half, or we can write it as minus 3 over 2 multiplied by 1 over the square root of x. Then substituting for the value of x in f prime of x, we will get minus 3 over 2 multiplied by 1 over the square root of 4 equal to minus 3 over 2 multiplied by half equal to minus 3 over 4. So let's substitute now f prime of a in m prime. So we get minus 1 over minus 3 over 4 equal minus divided by minus is plus, and now the reciprocal of 3 over 4 is 4 over 3. So now we have the gradient for the normal line. Let's now substitute all the given in the equation for the normal line. So we get y minus y1, that is equal to 2, we calculated previously, equal to m prime, that is 4 over 3, we just calculated, so it's multiplied by x minus x1, that is equal to 4, and this is given. Y minus 2 equal 4 over 3x minus 4 multiplied by 4 is 16 over 3. Therefore, this is equal y equal to 14 over 3x minus 16 over 3 plus 2. Let's take a common denominator for the constants. So we get 4 over 3x plus, we can take 3 as a common denominator. It will be minus 16 plus 6. This is equal to 4 over 3x minus 10 over 3. We can take this as the final equation, or we can modify the shape of the equation by multiplying all of the equation by 3, so it becomes 3y equal to 4x minus 10, and this can be written as all the variables on one side, so it becomes 3y minus 4x plus 10 equal to 0 is the equation of the line that is normal to the tangent at the given point where x equal to 4. So now after solving this example, you can go as a student to exercise, set of exercises 7H part 2, and find the equation of the normal using the same steps that we just did in this exercise.